Hello and welcome back. So we have been discussing forces in various contexts. As we get closer to solving motion problems in real life situations, our next step is to identify all forces that act on an object. And that's the focus of this video. This is an important first step in solving motion problems. In order to analyze the motion of any object, we have to know all the forces acting on the object, because the object responds to the net effect of all those forces. But in order to identify forces on the object, the first step ends up being clearly knowing what our object of interest is. So our first step is, given the situation, we need to identify the object of interest. Once we do that, we can think about the situation that the object is in, which leads to all of the interactions it has with its surroundings. And as we analyze these interactions, we can identify all of the forces that the various agents apply on the object. Now, in order to do this, step 2 ends up being drawing a clear picture of the situation. This picture will be centered around our object of interest. And then we will follow a few other steps to identify the forces, but let's start with an example that will help walk us through this process. Let's consider an elevator car that's in a tall building, and let's say in the elevator shaft the elevator car is somewhere between the 4th floor and the 5th floor. So here's your 4th floor, here's your 5th floor, and the elevator car is stopped in between those and hung by the cable that the car hangs off of. And there's a pulley somewhere here at the top, but that's not our interest. So for the physics picture that I'm going to draw for this object, I don't care about the elevator shaft, but I care about the elevator car and the rope it's hung by. So there's our picture of the situation. Next, having clearly identified our object of interest, which is the elevator car, we draw a closed loop around it. And I'm going to use a different color to do that so we can follow this. So here's the closed loop around our object of interest. The reason we do this is to identify the interaction points of the object with its surroundings, and since we know that other than weight, all the other forces are contact forces, they must exist along the boundary of this closed loop. So our step 3 here was to draw a closed loop around the object, and our next step is to go around the loop to identify all interaction points where forces are applied on the object. So in our case, I start here and I'm going around it, and the only thing that's coming in contact with the box is air, and in this case we are not considering air drag, so there is no force associated with it. Now when I get here, there's the rope that's interacting with the car, and we know that ropes apply a tension force, so we have a tension force over here, and it acts in this direction because we know that the rope is above the car and the tension force is a pulling force, so it acts in that direction. So in this simple example, as we went around the loop, we could only identify a single contact force. That's all we've got. And so our step 5 is to name the forces and create a list. And then as a final step before we are done, we need to consider the long-range force of weight. And since this elevator car is somewhere close to the surface of the earth, it does have the force of weight acting on it. So we need to list that over here. And because we know that weight acts straight down, I'll show that as an arrow there. So in this example, I only have 2 forces acting on my object of interest, which was the elevator car. One contact force, which was tension, and the long-range force of weight. Let's consider one more example to get this method down. So let's say there is a ramp here, and there's a box that's being pushed up the ramp by some person. And let's say that the surface of this ramp and the box is fairly rough. By saying that, what I'm implying is that friction is substantial in this case and cannot be ignored. And since I'm interested in analyzing the motion of this box, my object of interest is the box. So that's the answer to the first step here. We already have the picture. And now let's draw a closed loop around our object of interest. So here's our loop. Now as we go around it, let's start listing the forces. I'm going to start at the top here and go in a counterclockwise manner. So as I get to the person, I come up with my first force, and I'll call that the pushing force, and that's being applied up the ramp in this direction. Second, as I continue, I've got the contact between the box and the surface, and that contact has two forces, as we learned about before. The first one is the normal force, and since normal force acts perpendicular to the surface, if this is my surface here, the normal force would act in that direction at a 90-degree angle to that surface. Now, contact between surfaces has two kinds of forces. There's normal, and there's also frictional force, which in this case we could not ignore. So let's add friction force, and since the box is being moved up the ramp, friction force acts in the opposite direction of motion, so it acts down the ramp in that direction. And then as I go around the rest of this loop, I don't have any additional forces. So that's it. I've got three contact forces: the pushing force from the individual, normal force from the surface, and friction force between the surfaces. And as usual, I got to consider the long-range force of weight, and since this box is close to the surface of the Earth, it's got a weight which points straight down. So that's my inventory of forces in this case. This box has four forces that it's going to respond to. There's one final point I want to make here. We have two very different situations. We have an elevator car that's stopped and hanging, and we have a box that's being pushed up a ramp. The steps we followed for both of these cases to identify the list of forces acting on them is identical. In physics, we will give you a number of these recipes or steps that you can follow to work problems. And once you get comfortable following these steps, you will be surprised how solving seemingly very different problems becomes a lot easier. So in this video, we have spent some time understanding how to identify all the forces that act on an object. And we went through a specific set of steps that I'm not going to repeat since we have just gone over it, but here they are.